If you've been on LeetCode for more than a week, you've already felt it. A problem that looks simple, a recursive solution that seems right, then it times out. And someone in the comments says, just use DP. Dynamic programming has a reputation for being impenetrable, but that reputation is wrong. The core idea is one of the simplest in all of computer science. You've just never seen it drawn out. Let's start with Fibonacci. You know the sequence. Each number is the sum of the two before it. The recursive solution writes itself. It practically reads like the definition. But look at what happens when we trace the calls for f of 6. f of 4 is computed twice. f of 3 is computed 3 times. f of 2 is computed 5 times. Every branch is recalculating work that's already been done. By the time you reach f of 50, you're making over a quadrillion function calls. This is the problem DP was invented to solve. Not complexity in the algorithm's logic, redundancy in the work. Dynamic programming comes down to one insight. If you've already solved a subproblem, save the answer. Don't solve it again. That's it. That's the entire idea. Dynamic programming is just recursion with memory, or building a table from the bottom up. Two approaches, same idea. Let's see both. The first approach is called memoization, top-down DP. We still use recursion, starting from the top, f of n. But we keep a memo table. Before computing anything, we check, have I already solved this? If yes, return the cached answer instantly. If no, compute it and store the result. Watch what happens. Every subproblem is solved exactly once. The rest are lookups. Fibonacci goes from O of 2 to the n exponential time down to O of n. Same recursion, just with a memory. The second approach is called tabulation. Bottom-up DP, no recursion at all. We start from the simplest possible subproblems, the base cases, and build upward. f of 0 is 0, f of 1 is 1, those are given. f of 2 uses those two, done. f of 3 uses the previous two, done. We continue filling the table, each cell depending only on values already computed, until we reach f of n. No call stack, no recursion overhead. Just a loop filling a table from left to right. And notice, we only ever look 2 cells back. With a small optimization, we don't even need the full table. 2 variables. That's it. O of 1 space. So how do you know when to reach for DP? 3 signals. First, optimal substructure. The best solution to the big problem is built from the best solutions to its subproblems. Second, overlapping subproblems. If you trace the recursion tree and see the same calls repeating, that's your signal. Third, the question shape. How many ways can you? What's the minimum cost to? What's the maximum value you can? These phrasings almost always indicate DP. When you see all 3 signals, reach for DP. Memoize your recursive solution or build a table bottom up. Dynamic programming is not a mysterious technique. It's a very specific answer to a very specific problem. When you're computing the same subproblem more than once, stop. Save it. Reuse it. But dynamic programming is not a topic you can really cover in such a small video. What you've seen here is the entry point, not the full map. If you want to understand it in greater detail, including the different forms and variants of dynamic programming, subscribe and let us know in the comments. Thank you for watching and stay tuned.